I think so, yeah.
We'll see how that goes. For tasks to complete list, please go to the Science2 home page, and you're looking for tasks for Unit 1, Lesson 4, U1L4. Again, you can either look under assignments or you can go to the home page where we have that big weekly calendar. Look for today's date, which is the 18th, and there should see a Science2 AC plan. I'm condensing both the A period and C period, so that's what you want to click on is AC plan. And you should see what we're going to do today. As we've been doing, I just want to start off with a quick little collage share. I want to start with homework review. My bad. So homework was the carbon footprint data. And I'm going to put some people on the spot here. I apologize, but here is the data sheet as I can see it. And I'm seeing some numbers missing. So Sophia Bozo, I need you to enter your numbers. Brandon and Bryce, Grace Kirsch, and okay, I see some people entered things a little lower down. Bryce, I don't know why you're in here twice, but just need data from all of you, please. Submit that when you can. The introduce yourself flip grids look good. I got 15 in here, and I encourage you to watch each other's as well. And I haven't made my way through all of them yet, but I will soon. The Hewitt chapter 28.1 reading reflection was also due. Were there any questions on that? Was there anything you were confused by or needed help on there? In that Canvas quiz. All right, I assume we're feeling good. We'll do a little bit of review of that today, and we'll do some activities related to chapter 28.1 today. Okay, I just want to take a few minutes, do at least 2 collage shares, if not more. We've got about halfway through them by now, I think. So I've got them ready to pull up. Would anyone like to volunteer to go? Or again, I'll just select a victim. This is to share your Google collage you made last week. Bryce, you think you're ready to go?
Yeah, why not?
All right. Let's see. Do you know what you titled yours, Bryce?
It should be title Bryce-Ram. I can check real quick.
I can pull up a preview too here. Let me just preview some of these and see. There's a way to do a quick look.
I think the title has changed now. I made it Bryce-Ram, hopefully.
Okay. It's not that one.
That's Brandon's.
Right?
No, that's Brandon's.
Let's see. Oops. I go to the next.
Maybe that one.
Yeah. This doesn't update that quickly. Okay, I'm on that. Let's try to preview it.
Perfect.
Yeah. All right. Talk us through it.
All right. So, hi. My name is Bryce. I live in Carmel, California currently, but I was born up in Los Gatos, and I lived there for the majority of my life until I moved down here in 5th grade. And as you can see, I put the little beach and the thing for Carmel because Carmel is a beach town. I go to the beach a lot. I hang out with friends. Sort of what I like to do in my free time. And then another thing I like to do is football. It's kind of my favorite sport. I love watching it. And I also love playing it. Hopefully we can have a season this year, but doubtful, I guess. I also bike a lot with my brother and my dad, all around Pebble Beach and the Monterey Peninsula occasionally. And I put the little dude lifting weights because it kind of ties into football. It's what I do to sort of support that. And for what I'm interested in science, I would definitely say something having to do with astronomy and space and sort of physics and astronomy, so sort of astrophysics.
Nice.
I guess.
Yeah, and that's the topic we'll be getting into. So
yeah,
we'll see. I'm curious to see what's going to happen with the competitive league. I can't predict anything, but even if we had local scrimmages basically, or even within the same team, just so everyone can get playing a bit, I think would just be fun and good. So what kind of bike do you have? Do you have a road bike or a mountain bike that you ride around?
It's a road bike. We all have road bikes.
Nice. Fast. Great. All right, well, thanks for sharing. Anyone like to go next? Tristan, do you think you'd be ready to go?
Yeah.
All right. Let me pull yours up here real quick. All right, talk us through it.
All right. So I chose my guy as lacrosse player because I play lacrosse year round. It's my favorite sport. And then I chose the picture of college lacrosse in Notre Dame because that's where I like to play lacrosse in college. And then I chose a surfing image because I went surfing a lot this summer at Asilomar and Carmel. And then picture of Carmel Beach because that's where I've lived my whole life. Two pictures of animals because I like animal science. I think animal science is really cool. And I like genes and
Genetics. Nice. Yeah, animal science is zoology. That's what you're into. Great. I know you mentioned this before. You said on the lacrosse field you play in the middle, or what position are you usually?
Yeah, the midfield.
And you said you tried out for like a club team down in San Diego?
Yeah, I did in
Nice.
San Diego.
All right. Cool. Yeah. Well, it'll be exciting to hear back from them. So, yeah. Hopefully, again, we also like football. Hopefully, we get a little bit of lacrosse going once we're able to come back in January. Keep our fingers crossed. Okay. In the interest of time, I'm going to stop there. But again, we'll pick up with more of those shares. We've got about 6 left in total, and we'll get through those. So thank you for you two for sharing today. Next thing is I want to take a quick look and reflection on the carbon footprint data. Again, we're going to do a lot more with this later on. But on the tasks list, if you want, you can open up the Sci2A carbon footprint data. If you click on that, it actually takes you to a slightly edited version that I've created. And I'll share my screen here really quickly. It looks like this. I only got to work with the students who had actually submitted all of their data at the time that I made this. So there were only 9 students' data available for our class, but there it is right there. On the bottom, you can see I calculated totals for each category and averages. And I'm hoping right now it really stands out that can anyone figure out which category was by far the biggest contributor for the 9 students we got to see in our class? Sort of not surprising.
Transportation.
Yep. And most likely airlines, I would bet, that is giving that away. And purchases, interesting, was kind of the lowest. But I guess sort of given your age category and your age group, I mean, you guys shop a lot, but I don't think you're quite spending on things that are impacting heavily on carbon footprint as you will be once you start, buying cars and things like that. So just take a look at this data. I'm going to throw you into breakout rooms. And I've got some questions right there. As usual, just introduce yourself, and we're only gonna have 3 minutes. So just share your answers to these questions, right? What categories are the highest? Why do you think this is the case? Why is there so much variability between everyone? And just try to have a little conversation about what's going on there. Again, we'll time for 3 minutes and come back together to reflect a bit. Rooms are open, go for it. All right. I feel like I gave away a couple of the answers to that before we started. I shouldn't have even reflected on some of that data. Some interesting stuff that I noticed, though, just going to share my screen here really quickly. I always try to pay attention to the ranges of the data. So we established transportation was the highest. I mentioned that before we went into the breakout rooms. But what got me was which student has the highest number there for transportation? Which number? Student number what? Anyone see who's got the highest?
6. Oh.
Yeah, number 3 and number 6, which I find kind of interesting because number 6, being from South Korea, kind of makes sense. Probably flying a little bit more. If we had been here in class, then that definitely would have kind of accounted for having to fly here and back at least. But what's interesting is then there's the student from California who seems to have the highest by far. I can't quite, I mean, I could sort the data. I'm not going to take the time to do that right now, but it would be interesting to compare certain groups like California versus South Korea in this case, because we have such consistency with that, or male versus female, if there'd be differences there. This is the kind of data analysis we'll do with this when we get to our climate change unit. Anything anyone wanted to share though, or ask about, or anything you noticed in the data you thought was kind of interesting? As I said, we'll do more of that later. So if you have not entered your data into the actual sheet though, please make sure to do that. And I'll keep following up with that later. Okay. I'm going to let you go for some activities soon, but before we do that, I need to just quickly review some of the key points for chapter 28.1. I'll use the same sort of slide method that I've been using in the past, but keep it pretty short here. Okay, everybody seeing a slide in front of them? I'll need verbal confirmation. I can't see you guys right now. All right.
Yeah.
So welcome to the solar system. A lot of you have mentioned you're interested in astronomy. Here's our first little exploration and foray into it. I always like this diagram because it really shows you that we've got these 4 inner planets, right? That's Mercury, Venus, Earth, and Mars. Very small, very close together, and these tend to be what are called terrestrial planets because they're solid and rocky. And then out here, we have much, much larger planets that are way more distant from each other, appropriately called the outer planets, or sometimes referred to as Jovian planets. That's Jupiter, Saturn, Uranus, and Neptune. I often think of the outer planets as spelling sun, S-U-N, kind of helpful there. So Pluto doesn't count. It's technically called a dwarf planet. The reason for that is it has an uncleared orbit, which is, I know, is a weird thing to think, but all these other planets, they are the only thing in their orbit going around and around the sun. They're not going to smash into anything. Pluto has not achieved that point yet. It's basically sort of in its own little asteroid belt almost, and it has to continue to collide with things to clear that. You're going to be working today with a measurement unit called astronomical units, AU. And this is a common unit used by astronomers. Space is so big, and so they need a big unit to measure distances with, or else you're going to be working with ridiculously large numbers. So an astronomical unit is based on the average distance of Earth from the sun. So that's 1 AU right there, center to center. It's about 150 million kilometers. But don't worry about that. Again, we're going to keep it simple and just do 1 AU, 2 AU, and so on. You'll be measuring with that today. Chapter 28.1 also touches on nebular theory. This is a nebula. It's a collection of dust and gas that is the origin of a lot of solar systems in our galaxy and other galaxies. But the idea is that that's how our own solar system started. Gravity started to pull things inwards, and there was a bit of a spin that formed as well. And I think this is kind of the cool side of this solar system formation. It began to collapse inwards on itself, but it also was getting smaller. And so I like this little diagram here that shows that the faster and faster it spins, it actually flattens out. You can think of that as almost like one of those little softer spinning tops. If you ever had those as a toy that would spin, and it's going to flatten outwards. This also explains why all the planets have an orbit that's the same direction. There's no single planet that orbits opposite to the others, right? They are all orbiting in the same direction, and that's because of that initial spin that then the planets began to form in that outer debris. Then the sun ignited. So we actually had some planets forming before the sun was even actually technically a fully going star. But once the sun did ignite, it cooked those inner planets. That's why they're terrestrial, whereas the outer planets, which were more distant, managed to remain gaseous and much larger. And that is the gist of chapter 28.1. So we're going to do some activities to explore that today. Looking at your tasks to complete list, we are now on step 5, mapping out our solar system. There are 2 activities I'd like you to do, and both are going to involve Flipgrid. So if Flipgrid hasn't been working well for you, you can still, you can always email me the videos that you make. and get those graded. Just to show you what these are going to look like, the first activity you're going to do is called a pocket solar system. It's very similar to how we mapped out the history of the universe, but we're not going to use toilet paper this time. You should be using the paper roll from your kit, looks like that. And you'll also need a marker and scissors. If you don't have your kit yet, so if you don't have this paper roll from that science kit that was mailed to you, it's okay. You can still use toilet paper, or if you need to, you can tape paper together too. That might take a little longer because you're gonna need about an arm's length worth. But the assignment will walk you through everything. So I'll show you the assignment here one more time. I've got what you will need, and then I've got instructions for you to follow. There's a video you can watch. There's also, again, kind of a written description. You're going to be cutting the paper and then folding it to measure distances. But the point is to make a strip of paper that has the planets mapped out on it. The sun on one end, and technically Pluto and the asteroid belt on the other. But you're going to label Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And I then would like you to note the distances. Once you have them marked on there, there's the astronomical unit distances for them, because we're going to use that for the next activity. And once you're done with this, just take a quick video of your little strip, post it to the appropriate Flipgrid right there. So I'll give you 15 minutes to work on this before we move on to our next activity. I will be here listening, so if you're not sure what to do or if you have a question about something, just let me know. But otherwise, we'll get back together in 15 minutes. So you've got 15 minutes to work on activity 1, pocket solar system. Go for it.